Alright guys, welcome to this page of the notes, and again what we're doing here is we are solving expressions that have powers in them just to get some practice using the properties of exponents that you guys learned in Algebra 1. So let's just jump right into these. I got a number of example problems. We'll work through them together. The first one I have here is a quantity raised to a power, and so what you need to immediately think is that everything inside the quantity gets raised to the power. Let me show you what this is going to look like. I'm going to have a negative 2 raised to the third power. I'm going to have an a to the fourth, which will then be raised to the, you guessed it, third power, and a b squared, which will also be raised to the third power. Now, let me stop you right here. The most common mistake, or one of the most common mistakes that Algebra 2 students tend to make when it comes to properties of exponents is this. You guys always remember, hey, I got an a to the fourth, and it's raised to the third power. You multiply those exponents together, and you get a to the 12th. Awesome. You guys take a look at this and go, ooh, I got a b squared, but it is also raised to the third power. 2 times 3 is 6, so you give me the b to the 6th as well. But what a lot of kids forget to do is they forget this one right here. That coefficient, that constant, right? You forget to raise the constant to the exponent as well. That negative 2 also needs to get raised to the third power. So now that you know that that's a fairly common mistake, just make sure you watch out for it. Don't fall into that trap. You'll be just fine. Negative 2 raised to the third power is a negative 8. A to the fourth raised to the third. Multiply the exponents, and 4 times 3 is 12. B squared raised to the third power, 2 times 3 is 6, and so you wind up with a b to the 6th power. And again, I need to make sure that my fractions are simplified in simplest form. I don't have anything to cancel with the 8, so I'm good. I don't have any like bases, I no longer have any powers of powers, and I definitely don't have any negative exponents. So we got ourselves a winner. Let's go ahead and move on to the next one. Alright, once again here in this problem, I have negative exponents running around all over the place, and again, I just like to go ahead and get rid of the negative exponents first by moving them to the denominator and making them positive. You don't have to do it that way. Again, we're all going to get to the same place as long as you do your algebra right. In fact, you know what? Let's just go ahead. Let's do it that other way. You guys are watching live math here. This is not the way I generally like to do it, but I just want you to see it anyway. So let's go ahead, and instead of getting rid of the negative exponents first, I will start this time by combining like bases. Yeah, let's do this. So 2 times a negative 7, well, that's going to be a minus 14. Need a pen. There we go. Minus 14. Okay, so now, instead of me, what I generally would do is I'd take that x to the negative third, I'd move it to the denominator, make it an x to the positive third, and rewrite all these guys first. We're not going to do that. What I'm going to do this time is I recognize I have an x to the negative third and an x to the fifth. Those are like bases, so we add the exponents, which means I will now have an x to the negative third plus 5. Okay. I then have a y to the third and a y to the negative 6. Like bases, add the exponents. Y to the third plus negative 6. Okay, now that I've done that, let's go ahead and take care of that addition. So negative 14 leaves me with an x to the second, because a negative 3 plus 5 would be a positive 2. Then I have a y, positive 3 plus a negative 6 gives me y to the negative third. Right. I've gone ahead and now I've combined all of my like bases, right? So I don't have any like bases. Now I need to make sure that I reduce all of my fractions and get rid of negative exponents, which I do have a negative exponent. So I will have negative 14x squared. I take that y to the bottom and now make it a y to the positive third. The negative 14, which is to the positive first power, stays in the top because I didn't change its power. And the x squared also stays in the top, right, because I didn't change its power to negative, right? I didn't make it x to the negative second. If I had, I'd drop it to the bottom, but then I'd have a negative exponent. That completely defeats the purpose. So there you go. Your final answer. I got a couple more of these for you, so head on over to the next page of the notes. Let me go ahead and make these a little bit bigger for you. And let's just see what happens here. Okay, so I'm going to start off by reducing my fractions. 15 divided by a negative 3 would be a minus 5. Oh, I like it. Look at this. I have like bases top and bottom, which means I have division of like bases. So we're going to subtract the exponents. Remember, it's top minus the bottom. So this is going to be a c raised to the fifth minus 2. And then I'm going to have d raised to the third minus 7. And then we go ahead and do all of that. So I have c to the third power and a d to the negative fourth power. I can't have negative exponents, so move that guy to the bottom. I have now reduced all of my fractions. I have gotten rid of my negative exponents and I don't have any like bases. That guy right there would be your final answer. A couple more for you here. Let's try this one. Okay, great. So here's what I recognize. I recognize I have a quantity. It's raised to the negative third power. That means everybody inside the parentheses gets raised to that power. Let me show you what it looks like. I'm going to have an a to the negative third, all divided by 4. Yeah, you guessed it, to the negative third. Don't forget constants get raised to the negative third power as well. So here we go. Let's go ahead and do that. That's going to give me a to the negative third. Oh, hold up. You know what? Here, before I do that, let's do this. I'll go back to what I prefer. Negative exponent, right? Well, we know that we can get rid of negative exponents by simply switching their position in the fraction. The 4 is in the denominator. If I take that 4 and bring it to the top, it'll then be a 4 to the third. This a is to the negative third and it's in the numerator. So if I take that a to the denominator, it'll then be an a to the positive third. These guys are going to switch places. Hopefully you can see that. And what I've now got is a 4 to the third over a to the third. I just simply, right, they switch places. Take the numerator to the denominator, take the denominator to the numerator, and change the sign of the power. Well, a 4 to the third power is a 64, I believe. Yeah, 64. I can't do anything else to an a cubed. And that is as far as I can simplify. That one's done. Got a couple more for you here on the next page. Let me go ahead and jump over to this one. Awesome, here we go. A little bit more practice. I have a quantity raised to the fifth power. Once again, a pretty common mistake, don't fall for it, is that you forget to take the constants and raise them to the power as well. Just don't forget to do that. We know, of course, anytime you have a power of a power, you'll need to multiply those exponents. A negative 2 raised to the fifth power is a negative 32. And then it's going to be x to the 15th, y to the 10th. I don't have any negative exponents. I don't have any like bases. I don't have anything that I can simplify or reduce. And so that is going to be your final answer. All right, guys, here's what we're going to do on the next page of the notes. Head on over there. We'll try a few more of these, except I think I have you guys doing slightly more complicated ones. So I'll meet you over there.